Welcome guys. Before I see, we have question 2 coming from mathematics paper 2 for the year 2022 for the internal. So this question is coming from the topic of vectors. So let's read through the question. In the parallelogram or ABC, vector OA is equal to 4Q. So you can see here we have 4Q. Vector OC is equal to 6C. So this is our vector 6C. Then we have been given a condition from A to P is equal to 2 over 3 of vector AC. So 2/3 of AC is the vector for AP, and M is the midpoint. So midpoint simply means it's a point that is cutting a given line into two equal parts. So now let's look at the first question. So we are told to find, in terms of Q and slash or C, the vector AC. So if we want to move from A to C, so if we want, we can use the routes AO plus C or C, or if we want, we can use AB plus BC. Now I know someone may wonder, why are we using AB if we don't have the value? So remember, this is a parallelogram. It means this vector is equal to this vector. So since there is 6C, even here, this is 6C. So this line here is also equal to this line here. So here there is also 4Q. So we can use any route that we want. So let's just use AO. So we're going to say AO plus C or C. Now the vector OA is equal to 4Q. Now what of AO? So AO is the opposite in direction to OA. So we are supposed to introduce the negative to 4Q. So it's like we are moving in this direction. So it's against the arrow. So you need to use the negative. So this becomes negative vector 4Q plus C. Then for OC, this is just toward the arrow. So I'm going to just take the number the way it is. Then our final answer will be 6C minus 4Q. So that is our final answer. So we can now move on to question B. So under question B, we want to find the vector OP. So from O to P, we can use OA plus AP. So we're going to say OA plus AP. So what is the vector OA? So the vector OA is equal to 4Q. So this time we are just going to get it as a positive number. We are not going to change anything, plus C. So from this statement here, we are told AP is equal to 2/3 of the vector AC. So what is the vector AC? So the vector AC is this vector here. So it's 6C minus 4Q. So we can now expand. 2 over 3 times 6. So 2 times 6 is 12 over 3 of vector C. Number 2, 2 over 3 times 4. 2 times 4 will give us 8 over 3 of vector Q. So I can collect the like terms. So I'm going to say 4Q minus 8 over 3 of vector Q plus 3 can go into 12 4 times. So this will give us 4C. Then here we can now find the lowest common denominator. So the lowest common denominator is just 3. So here the simplest is same as we are going to cross the numbers and we multiply. So 1 into 3 is 3 times 4Q. This will give us 12Q minus 3 into 3. So 3 into 3 is 1 times 8Q will give us 8q plus 4c. Then 12q minus 8q will give us 4q over 3 plus 4c. So this is our answer. So OP is equal to 4 divided by 3 of vector q plus 4c. Right, so let us move on to question C. So question C, we want the vector OM. So let's look at this vector OM. So we want this vector from O up to M here. This is our vector. So to find this vector, we are going to use OC plus CM, since we are told M is the midpoint of BC. So we'll say OC plus CM. So the vector OC is 6 plus CM. So the CM, since CM is the midpoint, so we need half of the vector of CB. So remember, the vector of CB is 4Q. So what is half of 4Q is 2Q. So this is the vector for OM. So OM is equal to 6C plus 2Q. Right, so we move on to Roman number 2. Hence or otherwise, show that the points O, P, and M are collinear. So this is one of the challenging points under the vectors, showing that the given points are collinear. So let me come up with a different color. So our focus is the line where OP and M lies. So we can see that this is the line of interest. So this is the line of interest. So what I'm going to do for us to get sense out of this point is we need to get the two vectors that we have. So what are the two vectors that we have? So remember, we have the vector. So we have the vector OP. So I'm going to get the vector OP and equate it to the vector OM, since the two vectors lie on the same straight line. So let's do this. So you say vector OP is equal to, so this vector OP is equal to this vector OM. Now, after equal sign, you can introduce the scalar. So you can use letter K, you can use H, you can use any letter. So let's just use H of the vector OM. So the vector OP is this vector, we have it. So I'm just going to substitute. So OP is equal to 4 over 3 of vector Q is equal to OM is this vector. So OM is equal to H multiplied by 6C plus 2Q. So, okay, I've made a mistake here. So this is 3 over 4 of Q plus 4C. Then H multiplied by OM is 6C plus 2Q. So after this, what are we supposed to do? So on the right side, I'm going to expand by multiplying everything inside the brackets with H. So number 1, we are going to say H times 6C. So I'm going to get 6HC plus number 2, H multiplied by 2Q, we'll get 2HQ. Then upon reaching here, this expression that has Q, will be equated to this one that has the q. So the target is to prove that the value of h for this expression must equal to the value of h for this. So let's solve for h. So for this one, I'm going to say 4 divided by 3 of q is equal to 2h of q. So you can see that we have q on both sides, so I can cancel the q. Then I have 4 over 3 is equal to 2h. So if you want, we can divide by 2, or we can just cross multiply. So we cross multiply. We have 4 times 1 is just 4. 3 times 2 will give us 6h. So over 6 over 6. So what's our h? H is equal to, if we reduce, is 2 over 3. So if we can prove that this and this will give us 2 over 3, then the given points are collinear. So that's what you have to do. So let's see. So we have 4c is equal to 6hc. So c can be cancelled. Then we have 4 is equal to 6h. So we divide by 6, we divide by 6. So h is equal to 2 into 4 is 2, 2 into 6 is 3. So as we can see, this h is equal to this h. Therefore, the points O, P, and M are collinear. So for more examples of these, please feel free to join my WhatsApp line. So that's it for this video. Thanks for watching.